So in this video, I'm going to explain to you how digital sound works and how the questions in this area work as well. Sound needs to be converted into a digital format before you can store it in a computer. The reasons why is that sound is actually in analog form. When you speak, hear, or play music or sing, it's actually a continuous wave, it's analog. But computers only store things in digital format. They store things in ones and zeros. So they're actually digital devices and not analog. So we've got to do that conversion first. So how do you convert analog to digital? Well, this is one of those exam questions that comes up every so often. First of all, you've got a microphone that picks up analog sound waves. Those sound waves are converted into an electrical analog signal. What then happens is that you get your digital conversion. They read a value at a specific point of the analog signal, and they convert that into a digital signal. So what you end up with is a binary representation of the value read. So what we've gone through is we've gone from picking up sound waves, converting them into an analog signal, converting them into digital by sampling a little bit of the analog signal, and then finally storing it as a 1 or 0 representation. So here's a practice question for you to try. Try writing down your answers and then go back to the previous couple of slides to check whether you've got them right or not. When you record a sound and you want to store it in a computer, you need to think of two qualities that the sound has. The first one is what your sampling rate is. How many samples are you going to get per second? The lower the sample rate, the less accurate your sample will be. The higher the sample rate, the more accurate it will be, but the larger your file size. The other thing you want to think about is what happens when you're sampling. This is called the sampling resolution. How many bits are you going to store per second? Obviously, the more bits you use per second, the better and higher quality resolution you're going to have. But again, the larger file size you're going to have. So let's go over that a little bit more in a bit more detail. So analog sound has got two qualities, the length of the sound in seconds and the quality of the sound in terms of how good it is, how poor it is. Digital sound has got some very similar things, but also a bit more. It's got the length of a sound in seconds. It has the sampling rate, the number of samples you grab per second. It has the sampling resolution, the number of bits used to represent a sample. And if you remember from what I said before, the higher your sampling rate and the sample resolution, the better quality your sound will be. So what I'd like you to do is have a think about what those three variables, length, sampling rate and sampling resolution, might have on your sound files. And that's a bit of a Wally question. What might they do to them? Well, each one of those variables basically increases or decreases the size of your file. The higher your sampling rate, the longer your sound file, the higher your sampling resolution. That increases how big your file size is going to be. And obviously it goes the other way. The shorter the sound file, the less the sampling rate, the less the sampling resolution, the smaller the file is. So when you're storing digital sound, it's kind of a balance between how big do you want the file to get and how accurate or how good do you want the sound quality to be. One of the things you need to be able to do is calculate sound file size. And there's a very simple equation for this. The file size in bits is the sampling rate, that's in hertz, times the resolution, which is in bits, times the length of the sound in seconds. So here's an example. Sampling rate of 2000 hertz, resolution of 4 bits, length of 5 seconds. Multiply those all together, you get 40,000 bits. You'll get marks for your working, And just again, just a bit like the graphics, you can get asked to convert it into bytes or kilobytes or even megabytes. And remember that when you go from bits to bytes, you've got to divide by 8. And then when you go from bytes to kilobytes, you can divide by 1,000, and again on to megabytes, divide by 1,000 again. So that's a very typical question that they might ask you, and they will nearly always give you marks for the working as well. So here are some typical questions, both explain questions and also calculate questions, together with a kind of comparison question right at the end. Pause the video, have a little go at those questions. They're part of your homework for this week, and then I'll move on and explain the next little bit. So this bit is very similar to the amount of colours you can store in the graphics element that you did last week. In this case, it's about the number of bit patterns you can have, the number of different patterns that you can store for a particular sound resolution you use. And just like the graphics one, when you go up by 1 bit, so 2 to the 4 to 2 to the 5, you double the number of bit patterns you can store. I would pause the video here and have a look at how that fits together. Take a look at the way that the graphic on the right hand side fits together with this as well, so that you can get the idea that to calculate the number of bit patterns, it's 2 to the number of bits, very much like the number of colours you can store, and that going up by 1 bit doubles the bit patterns, and obviously going down by 1 bit halves the number of bit patterns you can store. Okay, so here are some more typical questions, in this case about the number of sound patterns you can store with different sample resolutions. Have a go at those, and again, these are questions that I'd like you to submit the answers to this week. So just a little bit of a summary of the impact of sampling rate and resolution on sound files. The more you increase your sampling rate and resolution, the higher quality you're going to get in your files, but you're also going to get bigger file size. And as you decrease the sampling rate and or the resolution, you're going to decrease the quality and the file size as well. Okay, and just an explanation of why those things happen. So as you increase the sampling rate, you take more measurements per second, you have less chance of missing out bits of the sound, so it becomes more accurate. However, you're going to increase your file size. If you increase your sampling resolution, you're going to store more bits for each sample. You're going to have less chance of missing out parts of the sound again. And again, you're going to get a more accurate representation of that analog sound, but again, you're going to end up with a much bigger file.